I'm going to be talking to you this afternoon about temperament and the role that a particular temperament may play in the emergence of social anxiety disorder in children. I just want to say just a few words before I start my formal presentation. In this world in which we are now thinking about personalized medicine, the idea of individual differences in psychology was not always accepted. Individual differences were thought of as noise. And now we are beginning to understand in medicine and in psychology and in psychiatry that the heterogeneity that we have dealt with for many years needs to be parsed apart to understand these individual differences in children's behavior. So these are the points that I'm going to be making. The history of temperament, something about comments about continuity and change, and then, as Thomas mentioned, I'll be talking about the temperament of behavioral inhibition and the role that it has in the emergence of psychopathology and particular moderators of early childhood temperament. Okay. So, just a few words on the history of temperament. We have always thought about individual differences in personality. Ever since the Greeks, you have the temperaments that Galen described, these four temperaments, and I highlight there the importance of typologies, that is, of these groups of individuals, particular kinds of individuals that have these particular types of personalities. But it was not until the work of two child psychiatrists, Alexander Thomas and Stella Chess, in the early late 60s and 1970s, that psychology and child psychiatry were introduced to the idea of temperament. They conducted what is now known as the New York Longitudinal Study, and they too talked about typologies, about different types of children. They had three. They called an easy temperament, a difficult temperament, and a temperament that was called slow to warm up. And really, in terms of thinking about it with a prediction to psychopathology, there was some work in the 60s and 70s and into the 80s on the role of difficult temperament in the development of particular behavior problems. More recently, Mary Rothbard, who is a developmental psychologist, who read the work of Pavlov and Eastern European personality psychologists, she proposed a model of temperament that involved both a reactivity and regulation, and an idea that one could measure temperament by looking at individual differences in reactivity and then subsequently individual differences in regulation. And I'll have a lot more to say about that in just a few moments. But it was also her partnership with Michael Posner, who is a pioneer in the area of cognitive neuroscience, where she and Posner expanded the idea of temperament in two ways. They thought that temperament could develop, and they also thought about it in terms of this regulatory aspects, that there were areas in the brain and executive skills that were developing over the first years of life and through the preschool years that were associated with the modulation of that reactivity, and there were individual differences in the way that those regulatory aspects developed as well. In terms of continuity and change, this is Jerome Kagan, who's a professor at Harvard University, and this was fundamental to his temperament research. In fact, in the late 60s, early 70s, he published a book called Continuity and Change in Development. And he was interested in identifying the factors that were associated with either continuity or change underscoring an important developmental approach. But also here, I emphasize that he was also very interested in typologies, in a particular type of child or in types of children, and the development of those children over time. But when we think about temperament and the emergence of psychopathology, there's been a tension, particularly in child psychiatry and in child psychiatry research, as to whether or not there are direct links between temperament and the emergence of psychopathology, or whether temperament is a prodromal manifestation of later psychopathology. And now this is not just a semantic argument, but it's an important one, because from a developmental approach, one can see temperament as being an initial starting state, and then there can be end states or changes in the temperament that can either remain stable over time or that can change as a function of environmental perturbations. On the other hand, seeing it as a prodromal state means that what you are looking at early in the temperamental differences between infants and very young children are the initial manifestations and symptoms of psychopathology. So here's how we've studied these questions, both in terms of early temperament and continuity and change over the last 30-plus years. We have done our work with longitudinal cohorts, and I'm just putting up here the study design for these two cohorts. This first initial cohort, they are currently 26 to 28 years old, and you can see that they were observed at 4 months, and then around a year, 2 years, 4 years, 7 years, again in adolescence, and then in young adulthood. And we are now recontacted them, and we're seeing them in adulthood at age 28. There are about 200 participants that were part of this initial study design. In a subsequent cohort, we also recruited those infants at 4 months of age, and we did similar assessments of these children in terms of behavioral inhibition, and I'll say a lot more about that in just a second, and then focused on the social interaction between those children and unfamiliar peers across multiple age points over development. And we also looked at friendship relationships and more intensively at executive functioning. Now, each of the cohorts that I've just outlined for you was recruited at 4 months of age from a large community sample of neurotypical infants for their reactions to novelty. They were presented with novel auditory and visual stimuli. They were observed, and there was microcoding that was done of facial expression and motor behavior. And from that, we identified infants that were high in negative reactivities, those that were high in positive reactivity, and those who were somewhere in the middle, which we used as a control group. When the children were either a year or 2 years of age, we assessed what we call behavioral inhibition. And the way we did that is we brought the mom and the child into the laboratory and presented that child with an unfamiliar adult, one of our friendly research assistants, with a mechanical robot that moved around the room, with a tunnel that they were asked to crawl through, and with a number of toys that they were asked to play with. And we defined children who were quiet and watchful and who ceased the activity that they were doing in the room and retreated from unfamiliarity. We called them behaviorally inhibited. These were young children who refused to engage in interaction, particularly in social interaction. Now, there is a link between this initial reactivity and behavioral inhibition that we measured at ages 1 and 2. So what you can see here in the 2 samples is that the children who are high in reactivity, both male and female in sample 1 and male in sample 2, are also higher in behavioral inhibition some 2 years later. So there's a link, as you see, between this initial reactivity, really what is the temperament, and then temperamental behavioral inhibition about a year to 2 years later. Now, what are the characteristics of children with behavioral inhibition? In our longitudinal studies, we've been able to characterize them quite closely. And we found that as they get older, they self-report low self-esteem, poor peer relationships, and they are often the victims of bullying, particularly as they enter into middle school. Because as the social context gets broader, they, in fact, are having more and more problems as children entering in and integrating into the social context. Physiologically, they have elevated cortisol, which suggests elevated stress reactivity. They have elevated autonomic reactivity, elevated startle responses, and right frontal EEG. Now, it's usually good to give you a sense about what these children are like. So I'm showing you here.
We had a bunch of people over, and he went over his presents.
I wonder if you could lower the volume just a bit. Thank you. This is a young boy that was identified at 4 months of age as high in negative reactivity, and he's in our laboratory. And you can hear the voice of our friendly female research assistant trying to engage him in play. And the mom is saying to our research assistant, well, you know, he won't play with any adults or any strangers. He just stays close to me, and he runs crying to me whenever anybody unfamiliar is around. And you can see that this young child will stay close and climb up on his mom's lap and refuse to engage with this very friendly research assistant during this period of time. Now, what we do next is at age 4, we bring this child back with 3 unfamiliar peers, all the same sex, all boys, and all the same age. And we put them into a room with lots of toys, and we observe their social interaction. So here we have free play between our target child and these 3 unfamiliar children. They're wearing these name tags so that it facilitates our coding of their behavior. Now, those of you will notice immediately that instead of a quartet, what we seem to have here is a trio. But here is our target child, and that's his mom that is bringing him into the room. But he does not want to enter into this playroom, no matter whether it has all these unfamiliar, these attractive toys. He really doesn't want to engage in interaction with the other children, and is quite distressed, actually, and in fact makes the other children distressed. Now, he'll settle down, and he'll do what we have called in the research literature reticent behavior. That's on-looking, unoccupied. And you can see there that he's going to sit and watch the other children for the rest of the free play session. He's not going to play by himself, although he could. There are lots of toys. He's not going to engage the other children. He's simply going to watch the other children playing. Now, at 7 years of age, we bring that same target child back into the room, and we bring another group of 3 unfamiliar, same age, same-sex children into the room. The room's bigger because the kids are now 7 as opposed to 4. and you can probably guess and pick out immediately who our target child is. Now remember, this is a child that we screened and identified at 4 months of age, who showed high distress and negative reactivity. At a year of age, he was high in behavioral inhibition. You saw him in response to unfamiliar adult. You saw him at age 4 displaying reticent behavior. And here he is again at age 7, and he is displaying reticent behavior. He's going to stand in the corner there during the entire free play session, and he's not going to play like these other boys are doing with these attractive toys. He's just going to stand there and watch, engage in socially reticent behavior for the entire 15-minute period of time. Now, what I'm going to do is I'm going to let this video run for just a moment more, because as you can see right now, one of the boys goes up to him and attempts to engage him. In fact, asks him if he wants to play, tells him he shouldn't be standing in the corner, and puts his arm around him. But our target child refuses to engage in social interaction. Okay, we followed these target children over time, and we have done psychiatric evaluations of them at multiple periods of time to examine what the outcomes of the behaviorally inhibited child are. And as you can see here, this is in adolescence. You can see that the yellow bars are the children who are high in behavioral inhibition, that they have a higher incidence of diagnosis, and in particular anxiety, and in particular social anxiety. This is at around 13, 14 years of age. Indeed, if you use the SCARED, which is a questionnaire measure of anxiety, what you find is that both the parent and the adolescent themselves are reporting elevated symptoms compared to non-behaviorally inhibited children. When we follow these children again at age 18, we find a similar pattern. This is, again, self-report on subscales, and you can see there that in terms of anxiety, the children who are high in behavioral inhibition, in fact stable high in behavioral inhibition, have heightened anxiety, and also, interestingly enough, are also reporting heightened substance use. This is at age 18, 21. We actually think that what this is about is that the children have now left home. Most of them are now in college or university in the United States, and some of them, in fact, use alcohol to deal with the anxiety of social situations. Here are the data in terms of anxiety diagnoses using the SCID, and again, what you can see here is that there is about 25% who are showing mood disorders, but a large percentage here who are showing anxiety disorders at 18 to 21 years of age. And again, there you can see that elevated substance use within this sample as well. Now, we are not the only ones who have followed these particular children over time. There are a number of different laboratories around the United States where they have identified children with behavioral inhibition and have gone on to look at psychiatric screening. And this meta-analysis that was published some years ago by Jenny Blackford shows that there is an enhanced odds ratio for children who are identified with behavioral inhibition for developing social anxiety disorder. Okay, so we've established that a temperament that can be identified early in the first years of life has an increased risk for developing anxiety, and particularly for social anxiety. But as a developmental psychologist, and I assume also for child psychiatrists as well, it's interesting and important to note that not every child that expresses or displays behavioral inhibition as a young child goes on to develop anxiety. Indeed, it's only about 40 to 45% of children that go on to show symptoms and express disorder. So what accounts for both this change and continuity, both the change in terms of children not showing the disorder or symptoms, and the continuity in terms of children showing these symptoms and then the emergence of this disorder in adolescence? I've put down 3 points, but unfortunately I really won't have an opportunity to review all 3. So the first we can obviously say is parenting, caregiving, the caregiving context. And we've done some work and published work on the caregiving context and the importance of it. The other is in terms of the child or adolescent social context, and I'm going to show you just one quick snippet of data in the next slide about how the social context can moderate temperament. And the third, which I will spend the rest of my talk about, is about the development of executive control. And if you think back to that PowerPoint slide that I showed you with Mike Posner and Mary Rothbart, and the development of self-regulatory behaviors and executive skills, really that's what we're interested in looking at, is whether or not the executive skills that these children are developing are not helping them to regulate this initial temperament. But just to give you one quick peek at some of the environmental context, this was a study that we did some years ago, published some years ago, and what we did is we asked and described the adolescent social network of these children. And what we found is that the children who were high in behavioral inhibition but had poor social networks, that is, limited social networks and poor quality social networks, they were much more likely to show anxiety disorders than those behaviorally inhibited children who had broad social networks and good quality social networks. Okay. But now let me go on to the issue of executive skills, and just to show you a picture, a schematic of the brain, and just to show you the areas that I'll be interested in talking about. The first is the amygdala, which is a subcortical structure deep in the brain. And the other 2 areas that I'll be mentioning are the cingulate cortex, particularly the anterior cingulate cortex, and prefrontal cortex, as both being involved in regulatory or executive skill behavior. Okay, and so we approached this problem of understanding executive skills by dividing up these skills into 2 different categories. One of them are reactive or automatic processing, that is quick, easy, efficient identification of differences. Think about it as terms of orienting or seeing the difference between 2 stimuli or detecting novelty. The other is more regulatory or controlled processing, which emerge later, involve executive attention. And you can see here that the areas in the brain that are associated with both the reactive automatic processing and the regulatory and control processing are quite different, although there are obviously networks that are connecting these 2 types of systems. So what about automatic processing? We have assessed that in our behaviorally inhibited children in a number of different ways. We've looked at attention orienting, attention bias to threat using a task called the dot probe, and we've also looked at response to reward. But I'm really just going to be talking about one particular piece of data, which is detection of novelty. And we asked the question, how early in life can we see whether or not there are temperamental differences in the detection of novelty? And so after we had recruited and identified our high reactive infants, we then brought them back, that was at 4 months of age, we brought them back when they were 9 months of age, and we recorded their EEG during a auditory oddball task. It's called a mismatch negativity, in which they hear different sounds, and they have to detect differences between these different sounds, as well as detect differences between different novel sounds. And what you can get from that with the EEG, while the infant is simply listening to these sounds, is an event-related potential called the P3, and that tells you whether or not the infant is sensitive to the detection of that novelty. And what you can see there is that amongst the high negative children, now all of the children detected novelty. There's the high positive children, here are the high negative children, and here are our controls. And this is the amplitude of that P3 ERP. But what is striking is that the high negative children, this is now at age 9 months, 5 months after we've identified them, what is striking is that they show greater sensitivity and greater detection of novelty compared to the other temperamental groups of children. In terms of controlled processing, I'm going to be spending quite a bit of time on this task. It's called the flanker task. It's been around for a very long time. It's a speeded reaction time task, and it's called the flanker because a participant has to press an arrow, press a button, one button if the arrow is going to the right, and another button is going to the left. And sometimes flanking the central arrow are the other arrows that are all going the same way, or the arrows that are going in different ways. These are called incongruent trials, and these are called congruent trials for obvious reasons. And the flanker effect is that you are slower in your reaction time to stimuli which are incongruent than you are to stimuli which are congruent. That's the flanker test. It was described in 1974 in terms of a speeded reaction time task. But more interestingly, Bill Gehring, who is a clinical psychologist and electrophysiologist, used this task with subjects who had OCD. And he, instead of synchronizing the EEG, while he recorded EEG during the flanker task, but instead of synchronizing it to the stimulus, he synchronized it to the response. And what he found is that 50 milliseconds after the response, after the subject made the response, there is a significant negative deflection called event-related potential, called the error-related negativity. You can think about it, and since we are in polite company, you can think about it as the brain's "oh darn" response. I've made a mistake. 50 milliseconds afterwards, before there's any conscious recognition by the subject that they have in fact made a mistake. And what we found, this is my ex-graduate student, Jen McDermott, who's now an associate professor at UMass Amherst. She looked at in our first cohort at adolescents with a history of high behavioral inhibition, and sure enough, what she found is that they had a larger negative deflection 50 milliseconds after they had made a response on the flanker task, after they had made an error. And you can see it there. But what was more interesting, and what Jen found, is that the magnitude of that ERP moderated the link between their temperament that was collected or described when they were young children, and now they're 13 to 15 years old. It moderated that link between their temperament and the odds ratio of them developing social anxiety disorder. Indeed, when she broke out the sample into those children who were high in behavioral inhibition who showed social anxiety versus those that did not, and here low behaviorally inhibited children, both with anxiety and not, it was only the children with social anxiety and behavioral inhibition who showed this heightened amplitude of this electrophysiological marker. They showed that they distinguished between those who were high in behavioral inhibition and were healthy, and high in behavioral inhibition with social anxiety disorder. We've replicated that moderation effect. This is Ayelet Lahat, who was a postdoc with me, and when the children were age 7, we presented them with the flanker task, and children with high BI have a larger amplitude ERN. This is this independently collected cohort of children. And what Ayelet also found was that, in fact, she found that same moderating link. So when they got the flanker task at age 7, and then we looked at whether or not they had social anxiety at age 10, those high behaviorally inhibited children with heightened ERP, this heightened error-related negativity, were more likely to have a social anxiety disorder. We've been interested in understanding exactly where in the brain this is all occurring, this error-related negativity, and there is imaging work that has been done. But these are collaborators of mine. That's Danny Pine, who's at the NIMH, Deanna Barch and Joan Luby, who are at Washington University, and Chad Sylvester, who at that time was a postdoc with Deanna and Joan. And we sent to Chad, we sent him the structural images from our behaviorally inhibited sample when they were 18 to 20 years of age. And we simply asked him to do a morphometric analysis and to see whether or not there were, to look at different structures, and particularly to look at the dorsal anterior cingulate cortex, which I mentioned appears to be an important structure in the brain that is associated with conflict detection. And here's the scatter plot that Chad sent back that we subsequently published. What you have here is on the x-axis, this is behavioral inhibition, with higher behavioral inhibition being in this direction. And what you have here is the thickness of the anterior cingulate cortex. And what you can see is that children who at age 1 and 2 were characterized with behavioral inhibition. 20 years later, the structural finding is finding that they, in fact, have thinner ACC compared to children who were lower or absent of behavioral inhibition. So what is this error-related negativity? I've told you a little bit about it. There it is. It's that negative deflection about 50 milliseconds when you make a mistake. It's the brain saying, oh, goodness, I've made a mistake before you even know that. And in electrophysiology, it is this negativity which is in the anterior portion, topographic anterior portion of the skull. We have done a source analysis of the error-related negativity over age, starting with 8-year-olds and going all the way up through adults. And what you can see here is that's the brain's response to correct responses. Those are the brain's responses to error responses, and that's the difference. And what's interesting about this particular study is that we did not find developmental differences. That is, the magnitude of the activity over the anterior cingulate cortex was similar whether or not you were an 8-year-old or whether you were an adult. However, we did find that these other areas that are connected, more anterior areas that are connected to the ACC, namely orbital frontal gyrus, insula, and the inferior frontal gyrus, they in fact showed this developmental differences. And so what you have here is you have this initial ability to detect. You saw that with the mismatch negativity with the 9-month-olds. And the anterior cingulate cortex appears in these behaviorally inhibited children to be active. But what is developing are the connections, anterior connections between the ACC and these other areas which allow for regulatory behavior and responses once you've made an error. What do we know about the ERN? Well, we know that it's elevated in anxiety disorders. I told you about Bill Gering's paper, which first described the ERN with OCD patients. We know that at least the ERN anxiety relation emerges in adolescence. that it appears to be enhanced in social contexts, and that it may be sensitive to individual differences. And we think, in fact, that it may be a vulnerability marker or a biomarker of threat sensitivity. We looked within our longitudinal data to see whether or not we can find evidence of temperamental differences in the first year of life that are associated with this error-related negativity in middle childhood at age 12. And sure enough, we found that. Here you can see that the infants that were rated high in negative affect, they actually had a significantly larger error-related negativity at age 12. So this is now 12 years later, 11 and a half years later, that we are measuring the ERN, and temperament, negative reactivity, negative affect and temperament, is predicting whether or not you have a higher ERN or not. In fact, if you look at the correlation, it's modest, but now you're going over almost 12 years in terms of these two data points. And what you can see there is that the higher negative affect, the larger the amplitude of the error-related negativity. I also mentioned that there's some reason to believe that there are contextual influences for the ERN. It may be that context, we know, in fact, that context is important for the elicitation, particularly of social anxiety. And so with our behaviorally inhibited children, we were very interested in manipulating the context and seeing whether or not that would change the magnitude of the error-related negativity. And we did that by pretending that our participants, these were 12-year-olds, they were getting online into an online chat room with other kids their age, and these other kids were going to watch them. We put a camera in the room. These other kids were going to watch them while they performed the flanker task. Okay, and we call that the social ERN. We also had the same target participants perform the flanker task when there was no social context. They were just in the room and they were told to just do the flanker task without any interruption. So obviously we counterbalanced everything and counterbalanced whether they got the social first or the non-social first. When we look at the ERN, what we find is that for the behaviorally inhibited children, the ones who were in the social context, when they were in the social context, the ERN was significantly larger than it was when they were in the non-social context. So the social context here is also modulating this biomarker for anxiety. And what we then did is we did a formal test of mediation because we wanted to know whether or not behavioral inhibition linked to social anxiety symptoms some 10 years later, how the social effect of the ERN and the child's performance on the flanker task, how they were linked to the emergence of social anxiety symptoms. And what you can see here is that although behavioral inhibition does predict social anxiety symptoms, more importantly, it predicts the magnitude of the ERN in the social situation and also a behavioral component called post-error slowing. Because in the flanker task, after you make an error, what people usually do is they slow down on the next trial. And that's called post-error slowing. And in fact, what you find is that behaviorally inhibited kids are actually much slower than other children in terms of their post-error response. So what are the implications here? Well, obviously, context matters. Errors hardly ever occur in isolation. And the worry, the threat for making a mistake usually occurs for these children in a social situation and in a social environment. We know that the ERN is influenced by motivation, and so therefore it is important to consider the context of the errors in predicting the risk for social anxiety. And when hypersensitivity to errors, which we know these behaviorally inhibited kids have, is maladaptive, and it leads to distraction, it leads to this greater post-error slowing, social anxiety is observed. And indeed, what we can now do using this formal mediation analysis is we can actually predict which are the children who are going to go on to develop social anxiety within the behaviorally inhibited sample versus those who are not. Okay, my last piece of data this afternoon is about reactive versus proactive control. There's a cognitive neuroscientist at Washington University by the name of Todd Braver who has done some elegant work about these two types of cognitive control. Reactive control, which you see there on the right, that is the kind of control that I've been talking about up until now. It's the immediate response to an error. It's the immediate response in a speeded reaction time task. It is the detection and resolution of interference. But what Braver also hypothesized is that there was also a particular kind of cognitive control called proactive control, which is more planful, so that when you know something is going to happen, you plan accordingly. If you're driving along and you know that you have to make a turn, you'll slow down. That's proactive control, as opposed to immediately swerving out of the way if there's a car that is heading towards you. So, Braver has this incredibly complicated task, which I won't have time to go into, called the IACAPAP, but it allows you to measure both proactive and reactive control, and we gave it to our behaviorally inhibited children at age 12. And we asked two questions. Is there a link between behavioral inhibition, measured at age 2, and proactive control? And is there a moderating role of this cognitive control in the relation between BI and anxiety? So first, is there a relation between BI and cognitive control? The answer is yes. Children characterized as high in behavioral inhibition, they are much less likely to display proactive control and more likely to display reactive control. And that is very similar in terms of reactive control to the error-related negativity that I've talked to you about. And do these different types of control moderate the link between temperament and later anxiety? So the answer is yes. If you look at those children who are high in proactive control, there's no temperamental effect. If you're high in proactive control, the likelihood of displaying anxiety or anxiety disorders is minimal. But if you are high in reactive control and low in proactive control, you're much more likely to display anxious symptoms and anxiety disorders. Okay, so in my remaining time, let me see if I can summarize. I hope I've convinced you at least that behavioral inhibition may be the best early phenotype that we have both in developmental psychopathology and in child psychiatry for the prediction of prediction of anxiety, and particularly for social anxiety. I can't think of any other phenotype other than if we want to discuss autism in very young children in terms of thinking about a phenotype where there is this kind of prediction to later disorder. But, as I mentioned at the beginning of my talk, there are individual differences, and not every infant that has behavioral inhibition goes on to display anxiety or has the emergence of an anxiety disorder. But it may in fact be that reactive control, like you see in the ERN with the flanker task and with other tasks that we did, or with the AXCPT, actually potentiates risk in these children. And the executive skills that are associated with this reactive control may in fact, we think, as I mentioned, it's this distraction, this post-error slowing, We think about this in terms of rumination, that these children worry about making errors, that they ruminate about what they are supposed to do next, and that stops them from being able to militarize or to get together, that's the wrong word, but to bring together the strategies that would allow them to cope successfully with their with social situations and with novelty and discrepancy. What are the implications for intervention? Well, I've just mentioned one, and it's one that we are actually starting right now. I mentioned that these children are, in fact, very rigid in terms of their responses. They are unable to break set. And so, and they are very reactive and not planful in terms of their responses to novelty and unfamiliarity. And so what we're trying to do is we're trying to teach them flexible self-control. And we have a computer game which we have them play in which they learn flexible strategies, and we have some preliminary evidence right now that that actually reduces the risk in behaviorally inhibited children from developing anxiety disorders. So, with that, my time is up. Let me thank all of the people who are listed up there who allow me to come to Prague and enjoy the city and come to this conference. Let me also thank my funders at the National Institute of Mental Health, National Institute of Child Health and Development, and thank you for your attention.